Alright, here's video number 6. We're getting on to the next page in IF for the final review for spring 2019. Remember, this list of concepts is not all-inclusive. You are responsible for studying everything we've learned and more this entire year. Okay, so now we're on to the average rate of change for these two tough questions on the last two tests we had before the stats test. Let's see, this question mimics this one right here, the average rate of change on this interval. And then this one was from about exponential functions. This one was, where is it? There it is. Remember that graph on the topic 5 test? Figuring out which one of these has a greater rate of change than this one. We're going to talk about both of these real quick on this video. Okay? Again, you got to know how to graph sine. Okay? My advice is always start off with what the parent looks like. Don't label the stuff yet. Let's see, 1, 2, 3, 4. That's our basic shape. It goes to these points right here. Let's just go ahead and make our basic shape. And then based on what the period is or what the amplitude is, we can modify. Well, there's no midline, so I know this isn't going to move up or down. So my amplitude is 2. It goes up and down from 2 to -2. But my period is going to be modified by 1/2. Remember, period for sine is 2 pi over b. Was 2 pi over 1/2? Well, that's 4 pi. So if the period is 4 pi, that means this spot from here to here measures 4 pi. So 0 to 4 pi. So we know that the sinusoidal repeats like this. Well, it's half of 4 pi. That's 2 pi. So that must mean this is pi, and this one's 3 pi. Okay, hopefully that makes sense, the logic on how to draw your parent shape, and then based on your parameters, fill in the labeling on the graph. That makes this part very easy. Now the interval is from 0 to pi, so the second one is pi over 0. I taught you guys to look, where is the function at pi? Where is the function at pi? Well, right there, it's 2. Okay, where is the function at 0? Oh, it's right there at 0. So this becomes very simple if you understand how to graph and how to interpret the average rate of change. That answer is just 2 over pi. Okay, let's do the other one. Again, I already calculated the average rate of change from this graph from 0 to 2, so it's 27 minus 48 right there. So we have negative 21 over 2, which is negative 10.5. But now what we have to do over this same interval is be able to plug this into each one of these equations and find out what the average rate of change is. Again, when you're given the interval, put that in for the bottom of your denominator, it's going to be the same. So all we have to do is plug 2 in with our calculator into each of these formulas and figure out what the numbers are. For sake of saving time, I'm going to just show you the C graph because I remember this one is the answer. Let's see. So 0.7 squared, order of operations, 0.7 squared, that's 0.49. Multiply that times 48. 23.52. So that's this value, 23.52, minus, what is this 0.7 to the 0 power? Anything to the 0 power is 1. 1 times 48 is 48. So it's going to be 23.52 minus 48 divided by 2. Divided by 2. Negative 12.24. And that is indeed greater than negative 10.5. Okay, that's it for this video.